So in this video, we're going to talk about how to solve compound inequalities. So a compound inequalities is anything that has like an and or an or. So the way we think about this is we need a number that is greater than -1 and also less than -2. It's kind of like saying, are you a blonde and a brunette? You would have to have like highlights in your hair or have just half and half. Like you need both to be true for an and to be true. However, like an or, if you are blonde or brunette, whether you're one or the other, you should still be answering yes to that question. So an or has much more, many more values that we accept versus an and. We need both to be true at the same time. So we're going to start solving these just like we did with regular inequalities and put them on the number line. So put the 2 on the right and the -1 on the left. And I usually do this as like scratch work off the graph. And I put an open circle at 2, and I shade to the left because x is less than, so the arrows go to the left. And -1 gets a closed circle, and we're going to the right because it's a greater than symbol and the bigger numbers are on the right. Now I'm looking for both of these are true. -1, x is greater than -1 would be true everywhere to the right, and x is less than -2 would be everywhere to the left. So the only place where they're both telling me the same thing is between -1 and 2. So we're going to just kind of sandwich this down and put them on the number line as a closed circle here at -1, an open circle here at 2, and then between them. Now, if they're both pointing to the right instead of to the left, then I would be shading down here on the right. But they're not. You see how these are overlapping over here? If they were both pointing to the left versus pointing to the right, then they'd be overlapping here, and I'd be shading in this area. But that's not what's happening. Right now what's happening is we're overlapping in the middle. So people get a lot of times the or graphs look like this, the and graphs look like this, where it's always in the middle, but they don't have to all be pointing in opposite directions. So what's the answer? The answer is this shaded region. So interval notation for this is a little bit easier to write than it was before. It goes from -1 with a bracket, and again, bracket happens when I've got the equal to, or when I've got a closed circle. And 2 is a parentheses because it's an open circle. So that's my interval notation. All the numbers from -1 to 2, including -1, but not including 2. So that's the basis of an and graph. Now for ors, you just need one or the other one to be true. So you put your numbers on the number line. So 4 on the right and 1 on the left, and you really don't care what one graph's doing. So I just need it to be less than -1. So I'm going to start here with a closed circle. You're noticing that I'm putting this directly on my graph. I'm not worried about putting it off the edge. And this is going to the left, so my arrows go left. And 4 is an open circle, and my arrow goes to the right. Because if you answer the question, if you're blonde or brunette, you don't wait to hear what the blonde say in the room. If you're a brunette, you just raise your hand. Like, the 4 doesn't care about the 1 doesn't care about the 4, so that's it. So what's my answer? It's both of these regions here. So how do I write that? It's a little bit trickier. There's 2 parts, so we're going to write 2 answers. So -infinity to 1 with a bracket because of the closed circle, and then from 4 to infinity is the other one, and the only thing that we have to make sure that we do is we join these up some way. So we'll use a little u. So or the union, or and then and does have a little notation for this. This is not like a U with a tail. This is always an open U. And it's called the intersection. So you could talk about it this way, and you might see it that way a couple different places in math, but we're going to use just the words or and. But this is the notation for and, this is the notation for or. So it's this or this. Alright, let's try a couple more practice problems. Alright, so let's try this first one. This was an or. So you put the -2 on the line, you put 1 on the line, and you just do what it says. So -2 is open, and that goes to the right. 1 is open, and that goes to the right. So what's the answer here? It's everything that's shaded. So what's shaded? Well, it's shaded from -2 all the way to the right, to infinity. Now, some people want to say something happens here at 1. But think about this saying something like, I want you to have more than -$2 or more than $1. If you have more than -$2, then you are okay with that statement. You don't care about this part. So that -2 kind of fills in the one's open circle. So this is actually closed at this point. And that's circle notation. When you have ands, you need both to overlap. So we put a 2 on the left, 5 on the right. 2 is going left. But remember, for ands, I usually draw this as scratch paper off the top. And 5 is a closed circle going left also. It's going left because it's a less than. It's the L, right? Both of these are L's. And the arrows also point to the left. Remember, the arrow, treating this like an arrow, only works when X is on the left side. So where are they overlapping? And that's what we're looking for when we talk about and graphs. They're overlapping here on the left. So from -infinity to 2. And you steal the circle at 2. So parentheses. If I want to put it on the number line, it would look like that. Alright, so let's try this one here. So we're going to put a 1 on the left, do it this way, and a 4 on the right. And I need it to be greater than 4, so over that way, and less than 1. Think about, like, just logically the numbers that would be bigger than 1, bigger than 4, and less than 1. I'm hoping that you're coming up with a blank here because there's no number that's bigger than 4 and also less than 1. So there's no answer to this. This is no solution. So this is not the answer. The answer doesn't have a graph. This scratch work does not go back down on the graph. That's just it. All right, we got one more type of problem that we're going to see here. And this is technically an AND graph. You could rewrite this as -1 is less than x and x is less than or equal to 3 if you wanted to. But the easiest thing is put -1 on the left, 3 on the right, and we have an open circle at -1, and you can put this directly on, and then a closed circle at 3, and x is between, so guess what? You shade between. Now if you do it this way, you still should get the same answer. The problem is, if you use it as an arrow left, you're going to be wrong, because x is on the right side, so if you flip this around, x is greater than -1, you would realize that arrow points to the right. And the 3 points to the left, and so they overlap in the middle. Alright, let's try to solve a couple of these where we have to actually solve them. So this seems to cause people a little bit of trouble. And so if you didn't have this left side, everyone would add 1 to both sides, right? Okay, but we do. If we didn't have this right side, then we would add 1 to both sides. So guess what? We add 1 to all 3 sides. So what we end up with, -2 is less than x, which is less than or equal to 3. And so then my answer is just -2 and 3 over here, closed circle at 3, -2 is an open circle, and then you're always shading in the middle for these. Whenever x is in the middle, you just shade in the middle. So our interval notation would be from -2 with the parentheses to 3 with a bracket. So let's look at B here. We got to try to write this as an inequality and then solve it. So twice the number increased by 7. So what does that mean? You take 2 times the number, increase, so plus 7 is between 13 and 17. So we're going to put this expression directly between 13 and 17. Now from here, the question is, what kind of inequalities do I have? Now what numbers are between 13 and 17? Well, 14, 15, and 16. But 13 itself is not, so we're not going to put the equal to sign on either of these. So we're saying it's between them, not including them. Now you can make some arguments either way, and you might want to check with your math teacher as to what they intend by that. But I don't think 13 is between 13 and 17. I think it's just the numbers that are between them. All right, so how do we solve it? We solve it like any other equation. So we pretend that this isn't here, or that this isn't here, and we solve it just normally, which means we're going to subtract 7 from all 3 sides. For some reason, people do just the right half and then just like totally ignore the left. I don't know why. So you get 6 is less than 2x, which is less than 10, and then divide everything by 2. So you get 3 is less than x, which is less than 5. So on the number line, you get a 3, and you get a 5, and you are shading in the middle always for these. So 3 to 5 with parentheses. Alright, let's do one more problem, kind of an intense one with all the fractions and all this fun stuff. So you get 2 different equations. So we're going to do the equation on the left, then we're going to do the equation on the right. Now the equation on the left has 8's on both top and bottom. Now you could distribute the 7/8 into everything, or you can just get rid of it by multiplying by the reciprocal, 8 over 7. So that's what I would suggest. Now on the right, the 8's are going to drop, and you're going to be left with 1/7. So 5x minus 2 is greater than or equal to 1/7. So 8 and 8 go. You have the 1 on the top and 7 on the bottom. And then you solve this just like normal. So 5x is greater than or equal to 7 plus 2. 2 is 14/7. So think about that. 14 over 7 would be 2, so we have 15/7. And then we got to divide it by 5. Now when you divide by 5, if I put the 5 up top, that's multiplied by 5. So you're really just putting the 5 on the bottom. So it's 35, or 5 and 15 is 3. So 5 goes in 5 once, 5 goes in 15 3 times. So x is greater than or equal to 3/7, which you could use a decimal too if you'd like to. Alright, so the second one, we got to get our x's on the left and our numbers on the right. So minus 5x over, and add 4/3. So we end up with a 1x is greater than, well, whatever 4/7 is plus 4/3. So if you want to do that without having to worry too much about it, we're going to take out our calculator and add 4/7 plus 4/3. You can't, please do not tell me that it's 8/10. You got to come to the common denominator. But if you don't want to think too much, and I mean, that's not too bad, but I can't make a 3 become a 7 very easily. It's not like you multiply top and bottom by 2. You'd have to make both of these become 21. So 4/7 plus 4/3, go to our calculator. So I can type that in as 4 divided by 7 plus 4 divided by 3, and you're going to get a decimal. That's a nasty decimal. If you want to turn it into a fraction, we're going to press the math button, and then number one's fraction, you hit enter, and then you hit enter one more time, and you get 40 over 21. Wow. Now also keep track of this 1.9. Let's go back to our problem. 40 over 21. Which was, over. Which we said was approximately like 1.9. Now over here, you've got this number, 3 over 7 is not bigger than 1, so this number is smaller. So the 3/7, so 7/7 would be 1. This is smaller than 1, this is bigger than 1. So you got to make sure you put them on the right order. If you put them in flip-flop, then they'll all be off. So 3/7, and this is or, this is closed, and it goes to the right. 40 over 21 is open, and that also goes to the right. So my answer in interval notation is just the shaded region. So bracket at 3/7 all the way to the right, to infinity. That's my final answer.